is Trev and welcome to my blog. A short while ago now I uploaded a video on repairing a MIG welder, and I promised faithfully that I would upload other helpful videos, which I never got around to doing. Usual thing, no time. Everyone can relate to that, can't they? Just total lack of time. And the other issue I've always had is my old computer is so slow. It's always such a hassle to edit anything, and it crashes and all the usual stuff. So I've dumped the new motherboard and processor in it, so it's turbocharged now, so it's so that's that sorted out. And so in this video I thought I'd do a tutorial on MIG welding. Now I've had a welder in my hand, one form or another, since 1986. Flippin' heck. And I work a few days a week in a restoration shop, which is extremely busy, so every day I'm welding there. The rest of the week I spend working for myself, normally with a welder in my hand. So I thought what I'd do is consolidate 30 plus years of experience into a tutorial to help somebody out who's requested a video on MIG welding. So this is for you, mate, really, and for anyone else that's interested. I'm nearing the end of a lengthy restoration on this 1960 British van. The next part of the restoration is to modify this front panel off the van. Now this front panel is a later front panel from the one that was originally on the van, and there are a few differences. This is the original front panel off the van, and the differences are in the grille area. The grille area on the original front panel has got a badge and chrome mouldings. On the newer front panel it's got a full grille. The reason I'm changing this front panel is because it's severely corroded in the corners. I'll call this part of the video the planning stage. This is where we need to work out the best way of doing what we've got to do. Each job needs to be weighed up on its own individual merits and handicaps for performing various tasks, such as welding in repair panels, either sourced from another vehicle or something you've made up yourself. So the planning stage is a pretty important stage, really. So weighing up this job, the differences on the front panel are these little brackets that are been spot welded all the way around, which aren't on the new panel. You've also got a series of holes for the badges as well to go in. The other thing I definitely have to change is this bar at the bottom, because on the later front panel this has got holes in, and on this front panel it hasn't. This will spoil the look of the van because I want to retain its original period features. So with the front panel turned round, I've been weighing up the different approaches that I could take, and I've come up with 3 solutions to the issue, and none of them are absolutely perfect. So I'll talk you through the solutions that I've come up with, and we'll discuss the advantages and disadvantages for each solution. So the first solution would be just to cut this panel out here. So I cut the panel through there, both sides. This would retain these 2 grill holes. The disadvantages of this would be the obvious badge holes and also the bracketry that holds the grill from the inside. The next solution would be this next cut line. So I could cut this center section out and weld it in. Now the disadvantages of this would be you've got this huge cut that you've got to get right all the way round, and the other disadvantage is that you've got bracketry for the bonnet that's on the inside of the front panel. So the third solution would be this third cut line, both sides again. This would remove the front panel, the front of the front panel in its entirety. The main disadvantages to this are fairly long cuts, but nowhere near this size of this cut in the center, and also keeping the front panel in a straight line. This could easily have the tendency to move when you weld it up, and you'd end up with a wonky front panel because this headlamp section could move backwards or forwards. You'd need lots of trial and error, lots of trying on the van to make sure everything was in the right place. So I believe really, honestly, I think that I should just remove this section here, and I could make a nice template out of the center section. So I'll take the center section out, perhaps cut the lips off so it'll lie flat against the new front panel. I can then use this as a template to drill my badge holes and my grill holes. I have to remove all the bracketry from the inside and the top and convert them over so that everything is bang on in the right place. So as you can see, it's a big dilemma and there is no easy solution to the problem. This is normally the case with every repair. There is always lots and lots of advantages and also lots of disadvantages, and nothing is ever as straightforward as it first seems. Poor old front panel. I feel really bad about having to do this, but as with all bodywork, it normally looks worse once you start before it starts looking any better. So with the panel gripped firmly at both ends, the next thing I need to do is to cut through the blue panel. What I intend to do on this one is, with my air saw, cut very tightly against the old green panel, possibly even just shaving along the very edge, maybe even removing a bit of the green panel. This doesn't matter at all. The objective is to get both cuts in the same place on both panels so that the panels align perfectly with each other once the cuts have been made. And I need to retain the gap between the two panels. We'll talk about the gap a bit more. I'll make the cut first and then we'll go into more detail about the essential gap. So I've just started making my saw cut and I've stopped making it because I want to just demonstrate something very quickly. I've left the very edge of the blue panel still intact. There's a good reason for this. As it's still intact, it's still holding together, which means that I can make my saw cut all the way down and the top of the panel isn't going to be flapping around in the wind. And I don't know if you can see it, but I'm just taking off the edge of the green panel. So the last sort of millimetre of the edge of the green panel is also being cut away. I'm trying to do this so that it maintains the saw cut in exactly the same place all the way round. If I waver away from the green panel and go slightly away from the green panel into the blue, what I'll end up with is a big gap down the side of the right in the middle of the two panels. There'll be a wider gap there. Not the end of the world completely, but it just makes things harder. So I'll cut these out and we'll get back to you then. So that's the blue part of the panel cut through, still trapped inside. I'll just pull it out. So there we go. That'll line back up to there. Both sides, of course. This is now discarded. And we've got a perfect cut between the old and the new. Next thing we need to do, clean this up really well. It's really important to get rid of every trace of old paint and rust, and I'll probably take it back to about here as well. You need it well away from the weld area. There's three good reasons for this, and one quite obvious, the other two not as obvious. The first reason, of course, is so that the welder can duct well to the surface of the steel. The other reason is that any impurities, such as old rust, old bits of paint and everything else, will interfere with the weld and introduce gases into the weld, make the weld very porous. It will blow bubbles and stuff like that. The third reason, which not many people really ever mention on these kinds of videos, is that old paint and old underseal, if it's burnt, the fumes that it gives off will impregnate the surface of the bare steel around it, and it will accelerate corrosion like you wouldn't believe. And that's another good reason to remove all the old paint from the surface. So that's what I'll do next. My preferred method of cleaning up old metal for welding is a cleaning strip wheel mounted to an old die grinder. We've got an angle die grinder as well, converted to a roll lock. So I think both these were made by 3M, and they remove stuff from the surface of the metal without grinding the metal down. So an angle grinder, probably not the best thing for this, because you're going to take too much material off. You want as much material on there as possible, because you're going to have to grind the weld down as well. You end up grinding everything really thin if you're not careful. So we're all gripped into place. What I'm going to do is I'm going to tack the 4 corners first, and we need to maintain a gap. I talked about the gap earlier, and this is really important, this gap, and I'll explain why after I've tacked this in. And with that little section welded in, it's all starting to look like part of the front panel already. Really pleased with the way that's gone in there. All feels nice and even and level. But what's happened is the weld has shrank and it's pulled the 2 panels together again. So we've got this tiny little gap which we need to put back to how it was before, the width of the hacksaw blade. Now there's 3 reasons why you need this gap. I'll explain what they are before I do any more. So the kind of weld I'm going to perform is called a skip weld. Skip weld basically means it's a series of small tacks spread out in time across the whole of the repair area, so that you're not concentrating any heat in one area too much at one time. So you've got your 2 panels and they're butted together, which means that they're facing each other like that. We put a small gap between the 2 panels, keeping them apart. Now if you didn't do this, it might be absolutely fine, but what can happen is the panel can have a tendency of rising up on the weld. And the reason it does this is because when you heat steel up, it expands. It expands quite a lot. And because the metal's got nowhere to go because of the lack of a gap, then they can only push together. It's also hot and soft because it's molten steel, and so it's softer in the weld area, and it allows it to rise up like that, and you end up with a situation where your welded joint is risen up just where you don't want it to be. Now the other reason, very important reason, is I've seen lots and lots of videos and they go on about weld penetration. Now they've devised all sorts of funny pliers to put angles on the edge of the steel so that the joint looks like that. So the joint, the edge of the panel's bent round, put together, and then you fill that little V'd out piece in. Don't like this myself personally. Now if you've got the gap there, you can even have the welder turned down quite low. It has to penetrate to the other side because the rod is going between the panels and it's arcing out, and it easily gets all the way through the material. The third reason is you can utilize this gap to maintain the panel's levelness. So both panels will have a tendency as you're welding to move slightly. You can simply put an hacksaw blade in the gap and then just shift it from one side to the other, leveling up the panels. So that's why. So let's get on and do some welding. So we have our first 4 tacks along each joint. I thought I'd just stop just to show you what I'm going to do next. So we've got the 4 tacks in place. Then just put your hand over, make sure that you've got a nice even joint between the 2, and I can feel that this blue side is very slightly higher than this green side. So as I said, simply get an old piece of broken hacksaw blade, put it in the gap and just move it very slightly, and that feels absolutely perfect now. You might have noticed that I'm using a lightly dampened cloth. What I do is I normally tack the weld, allow it a couple of seconds just to set well, and I just take the residual heat away using a damp cloth. I don't allow it to cool all the way down, I just really give it a dab. This just brings the temperature down quickly, a lot quicker than just leaving it naturally. If I had, say, I don't know, 8 of these joints, or these joints are a lot longer, then I wouldn't even bother with the rag at all, because by the time I got back around again, they would have all cooled down. And I never allow the joint to become wet with water, because what that will do is it will create issues when you're welding. You'll get the water boiling off and the weld ballooning again, filling with the steam. So that's a definite no-no as well. So what I'll do is I'll weld these joints up, and then I'll flip the piece over so that you can see that we've got good weld penetration from behind, and then it'll be grinding off time and we're completed on this task. So I've carefully ground the weld off, taking great care not to take too much of the material off the panels each side. Don't pay any attention to these little dimples here. They're just the old spot welds that were removed to remove the old grill brackets, and they're just the dimples from the spot weld tip. There's no holes there or anything, and they'll just be smoothed over with a bit of primer and a bit of filler afterwards. Let's see what sort of weld penetration we've got. Okay, so we're looking from inside the front panel again, just to check out the rear of the weld, just to make sure we've got good weld penetration. For anyone that's in doubt, you can see that we got real good penetration, baby. Well, thanks very much for watching that. Hope you got something out of it as well. I'm gonna have to do a part 2, aren't I? This video is really just specifically for a person that's just bought a MIG welder and needed to know the basics. So what I'm going to do is I'm going to do a part 2, and I'm going to put a few more of real useful tips, I believe, anyway. And I'm also going to make a small pressing tool, and I'm going to add that to the video. So it'd be quite interesting for anybody that's interested in fabrication and wants to learn a little bit more about making your own tools, really. I'm just going to give a quick couple of shout outs. Dave the Jag, he tipped me the wink or the nod or whatever that saying is the other day on his channel, so I'd like to reciprocate to Dave, so thank you very much for that. Dave is he's a Jag man. He does he's doing an E-type Jag restoration, and also he's got an XK150, and he's a mini man as well, so there's plenty going on. He does lots of updates as well on his channel for anyone that's interested in watching stuff that's being constantly updated, which you know, I neglect to do sometimes. So there's also him. There's Miniman Kev, I bigged up on one of my last videos. And one of the real important things I forgot to mention, Kev, was a video of mine was posted on Facebook, and somebody commented and they said it's really refreshing to see a restoration being done on a vehicle where the end value isn't directly linked to the restoration. And I believe you're very much from that camp, Kev, and it's really nice to see that, and it's something that's certainly a big part of my philosophy, which aggravates the hell out of most people that know me. So yeah, there's a few other people I'd like to mention too. There's Sean and Paul, they're both Minimen. Piper Doug, who's a complete lunatic. What I'm going to do, I'm going to add these channels I find interesting. I'm going to add it onto the video description, so if you want to check them out, check them out. If you want to see more content from other people. So I'll see you in part 2, where I'm going to do another video on welding at the same project, what's behind me. So yeah, and you can also keep abreast the Bedford enthusiasts of what I'm doing, because it's going to be the last part 20, so I'm going to sort of break it down and just keep uploading little videos of what I'm up to, so you can keep abreast of what's going on.